Alright, electric motor division 645, section 15, troubleshooting. Alright, engine troubleshooting, engine starting system, fuel system, lubricating oil system, cooling system, engine performance, injector pressure test, exhaust valve timing adjuster, hydraulic latch adjusters, timing injector, 1 revolution, inspection sequence chart, governor troubleshooting, turbochargers troubleshooting. Alright, the engine maintenance manual, electric motor division, GM 645, sections 15. Troubleshooting. The troubleshooting section is divided in 3 parts. The first, the engine troubleshooting, intent with the general guide of the troubleshooting of all 645 engines with the context of the general guide with the particular applications are noted. The second and third parts of the governing troubleshooting, the turbocharger troubleshooting, contain information applicable to only specific models designated with the cover of this application. Engine troubleshooting. Engine starting system. Starter will not crank engine. If the engine fails to crank, release the starting switch immediately with perform the following steps. Step for the proper battery charge with the inspected cable, the connection with the control circuit breaker. Check all the switches, circuit breaker with the engine control protective circuits are properly positioned. If the equipment has an isolation switch, make sure that it is in the start position. On the turbocharged engine, make sure that the turbocharged lube pump circuit breaker is closed. 5A engines with electrical starting, check the battery starter switch and fully closed by testing the start fuse with a continuity. Fire engines with air starting, check with the starting reserve the fully charged with the proper pressure free with the water accumulation, check all valves of the air line with the starter motors open. See if the engine is equipped with a turbo pump with a primary pumping security interlock. Make certain that the pump has activated with the interlock functions properly. While these steps have been performed, when these steps have been performed, another start can be attempted. If the engine still does not crank, leave the starting switch immediately with the proceed to the next step. No further starting attempts should be made until determine if the engine will rotate freely. Check that this can be done only by opening all cylinder test valves of the engine by the manual bearing tool. If the engine can be barred over 1 complete revolution, proceed with the engine cranking prevented by starting malfunction. If the engine cannot be barred over in 1 complete revolution, proceed engine cranking prevented by mechanical obstruction. Engine crankshaft prevented with the mechanical instruction. Remove the airbox handhold, cover the perform a complete visual inspection. Look at all the assembly, broken, damaged components. Check for debris of the airbox and liner pore area. Remove oil pan handhold, covers, inspect for damaged bent or connection rod, damaged counterweights, evidence overheated main bearing supporting A-frame, damaged low skirt of the linear cylinder liner. Check the ball position. Check all the piston cooling oil pipes, then place and attack the damaged piston. The cooling oil pipe is found with the related power assembly should be inspected closely for the damage. Note if the engine recently is overhauled, inspect all fork rod power assembly for the power matching series number of the basket assemblies. Misses match basket could result with a pinch connecting rod bearings in a shell. If the previous step has not been disclosed, any of the evidence of the failure is not possible to rock the crankshaft back and forth. The main bearing inspection should be performed. If the engine is turbocharged, proceed to step 5. 4B. If the previous step has been disclosed failure and is previously rocked, but it is possible to rock the crankshaft back and forth with no further evidence bearing with the failure of the engine driving accessory, equipment should be examined for seizure, checking the air compressor for the mechanical damage loss of the lubricant, check the main generator while the applicable design for the bearing heater, rotor, stator contactor. If the bottom of the air compressor for the main generator is satisfactory condition with the inspection of the front accessory and rear accessory auxiliary gear trains of the engine, the failed component of the gear bushing could be with the gear training of the binding which may prevent the engine from cranking. 5. On turbocharged engines, if the engine cannot be barred over in the direction of the normal rotation, reverse the direction of the engine barring it by installing the barring tool with the opposite side of the engine. If the engine can be barred over in the reverse rotation direction, then carefully inspect the turbocharger for rotor shaft binding. If the rotation of the turbocharger rotor is obstructed until the shaft has failed in one way, clutch engages, preventing engine rotation, normal turning direction, reversing the direction of rotation of the turbo. The clutch disengages the turbocharger out of the system. Are your engine cranking prevented by starter malfunction? Engine starting systems using separating electrical starting motors establish whether or not the voltage potential across the starting motors with the engine start switches in the start position. If the voltage present across the starting motors, remove the starter motor bench test in accordance with the instruction of the engine maintenance manual. If the voltage is not present across the starter motor, determine whether or not the SD or SDA is so equipped the contactors have been equipped. The starter starting contactor has picked up the check with the internal contacts for the damage. Check for the loose starting cables. If the starting contactor has not picked up the starting of the, then trace the starting control circuit from the opening interlocks or loosen and broke wire. Right. In the starting system, use the main generator of the starting. Establish if there is a voltage potential, cover the generator starting with the winding terminals. Add the generator with the engine start switches in the start position. 2A, if the volume voltage is present in the generator starting winding terminals, examine the generator itself with the damage of the bus bar connection with the start windings possible. Loose connection to the circuit. 2B, the voltage is not present for the generator. Start with the winding terminals. Determine whether or not the GS contactor has been picked up. If the GS contactor has not picked up, check it and see the internal contact for the damage. Check for the loose starting cables. If the GS contactor has not picked up, check for the starting control circuit if possible. Open and interlocking broken wiring. Engine starting system using air starters. Establish for the air pressure rate available at the start of the engine start switch for the start position. Air pressure available to starters. Then starters that should be removed at the bench test in accordance with the instruction in the engine maintenance manual. B, if the air pressure is not available to starter, the check of the air control start valve with the failure to pick up and check the closed valve with the restriction in the starting air supply lines. Starting engaged but cranking speed is too slow to start the engine. Engine starting system uses electrical starting motors. Check over the proper battery charge, preferably with the testing each cell with a hydrometer. Check the battery cabling, loose connection with the broken cable. Check the starting battery motors are properly voltage and are connected correctly with the battery voltage in use. Installation starter motors connected with a parallel accessory across the battery require that the starters have the voltage rating equivalent below battery voltage. Installation of the starter motors connected in series across the battery. 2 motors required motors which have an individual voltage rating of 1/2 that of the battery. Starting motors are different operation voltage rating are never mixed in the installation. Engine starting system use the main generator for the starting. Check for proper battery charge, preferably with the testing each cell with a hydrometer. Check the battery cable for a loose connection, broken cable. Engine starting system using air starter. Check the adequate air pressure for the reservoir that they are free of water accumulation. Check all airline valves are fully open. 3. Check that there is no restriction in or damage to the air supply line starters. Engine will not start with the crank at improper speed. Check the governor loop oil button is not out with the reset if necessary. Check the engine was assisted with the starting advance of the injector control level with approximately 1/4 of the total rack travel. No, if the advance in injector control lever was made, it taken about 30 seconds for the engine crank of the governor to move the injector rack from the fuel off to the idle position, which would allow the engine to start. Check the fuel supply with the cylinder by opening each cylinder test valve with the cranking the engine with the injector control lever in advance. The dense spray of fuel should be emitted to each cylinder. If the dense spray of the fuel is observed at the cylinder of the following steps should be performed. Check for the correct injector timing and the rack setting. Inspect the airbox evidence of the broken ring cylinder scoring. Either one can cause compression loss of the prevent starting. If previous checks disclosed no problems, qualify the engine valve timing of the performing exhaust valve timing check, refer to exhaust valve timing check within section. On both banks of the cylinder, only one power assembly each of the bank need to be checked. If the engine is out of time, check for the condition of the timing gear by performing an idle gear check. Refer to the engine maintenance manual. If the dense spray of the fuel is not observed at each of the cylinder, the following steps should be performed. Check for the overspeed trip if the lever is not tripped in position. Reset if necessary on units with an electrical fuel pump. Make sure certain that the control of the fuel pump switch is on and the fuel can be seen in the return fuel sight glass for the pump switch for the fuel prime position. If no fuel is seen, check the adequate fuel level in the fuel tank of the possible suction links and or plunge suction strainer. If the fuel is flow is seen in the bypass fuel sight glass, change the engine mounted fuel filters. On an engine driven manual prime fuel system, prime fuel pump installation, make sure the system was properly primed with the hand priming pump prior to starting. If no resistance was noticed while using the hand pump, check the adequate fuel level, the fuel tank suction leak, and the plunge suction strainer. A jam fuel line check valve with extreme resistance was noticed while using the hand pump. Check for the plug fuel filters. Fuel system, low fuel oil pressure. Check the adequate fuel supply with the main fuel or day tank. On locomotive installation, engine mounted fuel sight glasses observed 60 psi bypass sight glass to make certain that there was relief valve on the sight glass assembly was not struck open. On other installation by the bypass pressure relief valve, the inlet side of the fuel filter for the tank return check with the bypass and the or relief valve is not stuck. Observe the pressure drop across the fuel filters. Pressure drop near or above the change out value given in the filters. Replace the filter elements gain. Again, observe the fuel pressure. Note, use only recommended filter elements. 4. Check the engine oil level to determine the fuel oil level by leaking the engine lubricating oil system. Inspect the top deck air of the bowl cylinder banks, leakage of the injector jump liners, the top deck fuel manifolds, installation, no return fuel sight, glass of the engine driven fuel pump. Inspect all suction line with the air leaking into the line. Check pipe connections, unions for proper tightness. Remove the inspection with the screen of the suction strainer. Clean if necessary. Check all the suction piping of the recommended with the diameter large. Install the return fuel sight glass for the electrical fuel pump. If the bubbles are screen with the fuel sight glass while the engine is running, then shut down the engine fuel and hold the prime engine start switch until fuel prime. In the fuel prime, continue to observe the sight glass. If the bubbles disappear after the engine shut down, the probable cause of the bubbles was an injector with a tip leak. If the bubbles continue after the engine shut down, fuel prime engine start switch is held in the fuel prime position. The probable cause is a fuel suction leak. The fuel suction leak may cause air binding of the system, and the loss of fuel pressure of the fuel system should be followed to eliminate the fuel suction leaks. Inspect all pipe connections, unions in the fuel section line and the proper tightness. Or when locomotives installation, inspect the coordinate additions of the check with the tightness, all piping and leading and out of the fuel tank, clean with the screen element of the fuel selection strainer if necessary. Alright, 6. On units equipped with the fuel preheater, remove the body end of the caps, inspect the internal heater header bends of the pot for possible trap material obstruction of flow of the fuel from the heater. Inspect the supply with the bypass circuit with the fuel suction line partially closed valve. Inspect fuel pump itself with leak for the damage. Inspect the pump drive coupling with the drive of the shaft key with the locking screw. Foreign material in the fuel supply tank may be the intermittent obstruction of the pickup of the fuel drain. Fuel tank then does not solve the problem when it is necessary to open the fuel tank and inspect the foreign material. Alright, your lubricating oil system. Many oil system problems as well with the engine overall engine troubleshooting problems can be easily identified with the lube analysis. Refer to Table 1 for the interpretation analysis statement. Lack of delivery from the scavenging system and installation except for the marine engine with the engine-mounted raw water pump. The preliminary setup of the troubleshoot with the scavenging oil system should include the installation of the pressure gauge 0 to 50 psi with the quick disconnect fitting on the machine filter tank. External source of the cleaning of the engine and lube oil must be supplied with a maintained oil gallery while the troubleshooting lube oil system is sufficient with the quantity of the lube oil necessary to protect the engine and the bearings. Before starting the engine, check the adequate supply of the oil and oil pan. Make sure the strainer housing with the fuel full of oil within 2 inches of the screen under the large cover. Also under the large cover to make sure that the machine tank drain valve with the T-handle is fully closed. Remove the scavenging pump with the core strainer with the elements with the help of the strainer box and 3 bolts. Inspect the interior of the suction strainer of the foreign material to clean if necessary. Make certain that the strainer is installed with the gasket and tightened securely. Remove the several oil pan handhold covers. Inspect the entire length of the oil suction line leading over the governor end of the engine to the oil sump. The mechanical damage of the engine. Any mechanical damage to the line must be repaired before operating the engine. Starting the engine, observe the oil with level in the strainer box. The oil level of the strainer box does not return approximately 2 inches out of the screen within 45 seconds of the engine start. Take the reading on the machine and tank pressure gauge at idle. Shut down the engine. And again, the engine can be shut down by pulling out the oil strip button with the governor rail engines, or by tripping the overspeed shutdown lever of the marine engines. If the pressure reading is low zero or lower zero, scavenging oil pump with the suction line with the strainer box should be inspected. Necessary with the scavenging oil pump should be removed and overhauled. If pressure reading of the oil was higher than 10 psi with the change of the oil filter elements, repeat the procedure. If the pressure was still high, then remove the clean with the oil cooler core. The oil level of the strainer box does return within 2 inches of the screen after starting the engine. Operate the engine slowly, increase the speed. Observe all the oil level of the strainer box and all engine speeds. The maximum operating speed taken the reading of the machine tank pressure. The pressure readings given with the applicable only the insulation radiator type of the oil cores. The switcher locomotives, industrial engines which shelve the tube with the bundle with the coolers, and use alternate pressure readings provided with the switcher locomotive industrial engines. If pressure reading with above the 25 psi change filter elements, note use only electric motor division oil filter elements are equivalent to the machine oil filter tank. If the pressure is reading is 10 psi after changing the filter elements, remove the clean of the oil core. After pressure reading of the 3 psi, check the machine and tank bypass valve to determine if it is jammed open. Switcher locomotives, industrial engines, chain filter elements of the 50 psi. If the pressure is above 20 psi after the filter is changed, then the clean oil cooler. If the pressure is below 10 psi, then check the bypass valve to determine if it is stuck open. Or your marine engine installation with the engine mounted with the raw water pump. The engine is considerably different with the electric motor division engines that much over the oil with the system piping is installed with the outside of the contact. The variation would cause the normal pressure characteristic of the oil system to be altered. Preliminary setup of the troubleshooting with the scavenging oil system include with the installation of the pressure gauge 0 to 50 psi with the filter tank connection labeled the inlet with the external source for the cleaning engine and lube oil that must be supplied with the main oil gallery while the troubleshooting of the lube oil system. Sufficient quantity of the lube oil is necessary to protect the engine bearings. Before starting the engine, check with the adequate supply of the oil in the oil pan. Before remove the stream with the check for any of the obstruction of oil flow. With the check with the stream with the necessary to install with the stream with a good gasket with the tightened securely. Check with the scavenging suction line with the oil pan and with the any mechanical damage of the line must be repaired before starting the engine. Make sure that the lube oil system is primarily hand pumped to the drive drain valve is fully closed. Starting the engine with the observe the pressure output with the scavenging pump at idle speed. With the pressure output less than 10 psi, qualify with the following components in order listed with the specified. The check with the valve that makes certain that they are not stuck open. Main lube pump and the suction relief valve, filter bypass relay valve, the lube oil cooler bypass relay valve. D, the scavenging oil pump. If the pressure out greater than 40 psi, check with the pressure differential across the lube oil filter elements. The pressure differential exceeds 10 psi, the change the filters and retest. Check with the pressure differential across the oil cooler. If the pressure differential exceeds 10 psi, then clean the oil cooler. Engine at full speed. Check the pressure differential across the lube oil filter with elements. Pressure differential must not exceed 20 psi. Check pressure differential across oil cooler. Pressure differential not exceeding 20 psi. Due to the greater oil system capacity, inline strainer with the scavenging oil pump at the 20 cylinder engines occasionally exhibit no linear oil pressure response or oil pressure due to the flow of the engine RPM. Except the use of lubricating oil, preliminary inspection checklist is provided with the indicating possible areas of oil loss. Inspect the jack of the car body roof for the evidence of oil loss. Then inspect the engine exterior for leaks. Airbox drain should be inspected for oil loss. For the coil and water expansion tank should be inspected by indication of the oil film on the top of the side of the water surface. Inspect all drains, determine if they are partially open, and instruct the check the oil level of the governor sight glass engine oil by leaking in the governor oil of the rail raise the level in the sight glass. If this occurs, the considerable external oil leakage will also be visible on locomotive installation. Inspect all external piping, load regulator, vane, valve motors, or for oil leakage. For other marine stationary items installation, use the pedestal bearings. Inspect the bearing housing, all external oil lines. For any sign of oil leakage, the brand name of the viscosity of the lubricating oil should be established. Use the oils should be confined with the use of the qualification published in the EM Electric Motor Division. Use any of the improper oil or oil that is not correct with the viscosity can be contributing factor to the excessive oil consumption. Alright, your oil loss out of the exhaust stack of the perform airbox inspection. Pay particular attention for the condition of the piston rings. The line of the worn rings should be replaced with aware of the receive the recommended limits provided in figure 15.1. Broken rings should be replaced immediately regardless of the wear status. Note the condition of the piston crowns may be used with the indicator. Isolate with the troubleshooting procedure with the specified cylinder. Excessive wear crowns and carbon throw off of the inlet ports may point out with the cylinder with the oil control problems. The oil separator should be disassembled with the verify the presence of the separator screen on the turbocharger end. Of the absence of the screen can cause excessive oil consumption and oil out of the stack on the blower engine. The absence of the screen can cause excessive oil consumption on the blower engines of the air chute with the blower over the airbox. They should be inspected by the inside airbox by evidence of the oil delivery down with the chute. If the oil is found running down the chute, the blower should be removed with the blower rotor with the end of the seal replaced. On turbocharged engine, the turbo screen with the tapper joints should be removed. The exhaust manifold interior should be inspected to determine if the oil loss is originating from the engine with the turbocharger. In many instances, with exhaust manifold inspection will relieve the specific cylinder response of the oil loss on turbocharged engine. With an inspection with exhaust manifold indicate that the problem with the originate with the turbocharger with the inspect of the air inlet system for plug filters. The plug filters kick off the high inlet vacuum with the drain of the oil path of the turbocharger. The labyrinth seals its external system with its valve to be in good condition, and the change of the turbocharger may be necessary. Engines operated with the extent of the period of time under light or no load may be experienced varnishing with the cylinder wall. Varnishing greatly will reduce the effectiveness of the oil control rings, can cause the condition known as souping, or souping can cause light brown or tan deposits of the cylinder liner walls. Light loaded operation continue with the varnishing deposits may interfere with the ring with a delineator or seal with a defectiveness. Extreme instances, light load operation may be necessary to load engine either with a temporary change over the surface or through the use of a load box in order to remove the deposits to restore the efficiency of the ring set. In instance with extremely severe oil loss through the souping at the stack or through the airbox drainage, experiment with the shop of the overhaul practice should be investigated on EMD 645 engines. Piston rings of the number 4, number 5, and 6 screws are directional. And then it shows you a chart of the chrome ring wears classification. Alright, since the installation with all 6 rings that are set with must be properly and oriented with the correct slot in the installation direction and orientation of each of the rings is provided. Number 1 ring at the top of the groove only stamped with the part number that may be installed with either side up. Number 2 and number 3 ring are identical. They are both stamped and the part number that may be installed with either side up. Number 4 is labeled at the top, has a part of the number stamped on it. It must be installed with the top labeled upwards, not only with the number 4 slot, but the ring is installed with the upside down and the tapered face that will tend to pump oil past the upper compression rings. Number 5, the double hook scraper must be installed with the hooks pointing down. If the ring is installed with the upside down, they will cover the heavier oil off the air ports of considerable oil draining in from the air box. The number 6 ring with a special spring loaded scalped oil control ring must be installed with the scalps downward. The ring is installed with the upside down. The oil cost control efficiency will be greatly reduced and may result with excessive oil loss. Note, at the time of the overhaul, if the rings are removed, the troubleshooting is substitute use of the lube oil. Make certain that the oil drain holes under the oil control rings are not clogged. External engine links leakage of the oil from the engine will generally require the tightening of the effective part of the replacement of the gasket. Loss of the oil from the airbox drain. The perform a complete airbox inspection replace any of the power assembly that are found to be scored with the running of excessive warm rings and inspect the air delivery chutes for any of the sign of the oil leakage for the airbox of the route of the blower and turbocharger. Investigate shop practices proper installation piston rings denoted as oil loss out of the exhaust stack. Or inspect the excessive oil leakage from around the power assembly with the center gallery with the airbox leakage. If the air might indicate the failed or absent seal of the component. 5. Inspect the air box piping with the oil pan from any of the oil evidence leakage or the external damage of the piping that would cause the oil loss. Oil in the water expansion tank. The indication usually seen with the installation shell on the tube type of oil coolers because of these, and the cooler's local oil pressure is higher than the cooling water pressure. On the installation with the fin type of oil cooler's pressure cooling system with the water pressure with the high of the oil pressure in the cooler because of the pressure of the difference inside of the cooler, the internal leak that usually resolve the water contamination of the lube oil pressure of the test qualified with the oil cooler for leakage. Leakage sump drain the pipe plug should be retightened the valve. If so, the equipment qualified to replace loss of the oil to the governor. Low oil pressure actuating diaphragm of the governor should be replaced. The load regulator pipe of the vane motor leaking and the tightening and replacing is applicable. Improper viscosity of the oil contamination. If either improper viscosity or oil contamination is suspected, immediately take the lube oil sample analysis for the specified corrective actions indicated in Table 1. Interpretation of lube oil sample analysis. If necessary, area pressure test of the fuel of the cooling system as required to isolate the source of the contamination from further dilution of lubricating oil. Pedestal braking leakage marine. Replace the bearing seal of the check with a return line with a continuing check of the orifice of the place of the supply line. Low engine pressure. When troubleshooting low engine oil pressure, it must be first determined the problem is an adequate supply of oil through the pump input with the warm defective pump, the sum of the component with the pump output with the circuit causing the pressure loss. Lubricating oil should be qualified to ensure that it is not diluted, which would cause the pressure drop. Check for the adequate oil level of the engine oil pan. Observe the level oil with the strain box. The strainer box, if so, equipped with the engine idling over the oil should be visible within 2 inches below the screen inside of the rectangular cover. The oil level strainer box is low. The scavenging oil system is suspect. Inspect the scavenging pump with the scavenging pump strain with the machine filter with the tank and an oil cooler with the outline with the lack of the oil delivery from the scavenging system. If the oil system pump of the main pump is found with the adequate with the auxiliary oil pressure gauge 0 to 150 psi, that should be installed with the outlet elbow of the main lubed oil pump shoe using a 3/4 inch NPT plug hole. The main pump with the pressure that reads auxiliary gauge is still low. The following checks should be made. Remove the tooth line, screen the strainers, the strainer housing, check the strainers, inspect the seal for the possible suction leaks, drain the strainer box, inspect the chamber for any of the form to remove the blowdown compressed air within the seal vent line to make certain that they are not obstructed. Remove the oil pan handhold, cover the visually, inspect the external surface of the main connection rod bearings, evidence of heating, locking for missing or loose components, operating the engine idle, remove the engine protector for the observe the pressure relief valve located directly behind the engine protector for the excessive oil loss. If the valve is found to be stuck, the open position should be removed and replaced with a qualified valve. 4. Check the suction link for the main pump inlet with the elbows, which remains the main pump to the strainer housing to replace the gasket. If necessary, remove the qualified with the main oil pump. It was found that the main pump, if it was found that the main pump pressure was adequate after the installation auxiliary gauge, then the following steps should be performed. On the turbocharged engine chamber, the turbo oil filter element should qualify the main engine oil pressure. Inspect any of the closed valves in the supply line with a gauge. There's a 1/8 inch diameter line leading through the right of the bank to the top deck of the engine pressure gauge. Inspect the line for the carefully with the damage necessary to disconnect the line at both ends of the blow air through it to make certain that it is clear of obstruction. If the main engine oil pressure gauge is found to be correct, the defective engine protected device could be causing the fail oil pressure drop. The engine protected device must be checked. Disconnect the block connecting the line over the oil pressure sensing line to the engine protector. Hot oil shutdown is so equipped. If the result of the restoration, normal oil pressure drop reading of the main engine gauge indicate one of the following areas. The O-ring seals of the engine protector plunger have been failed. The activation section of the hot oil detector may be jammed open. If 2 qualifies both these devices, if the engine protected devices are found to be in the proper operation condition, an auxiliary oil pressure gauge indicates the adequate main pump output pressure, and the main oil pressure gauge is still indicating inadequate oil pressure. The investigation rear gear train over the engine over the possible cause of low oil pressure. This should include the following. Note: the engine should be shut down for these checks. Use the recommended tool for the check of the clearance, the numbered 1 idler stub shaft bushing at the same time. Inspect the interior of the end of the housing with the debris under the gear train. Under the unturbocharged engine, remove the auxiliary generator drive. If so, equip the cover plate with the rear of the right bank. Inspect the manifold with the turbocharged filter for the loose of the missing connection components or seals. Make certain that the upper pipe plug is installed with the gauge line with the connection block. Connecting block and inspecting the cam manifolds on the blower engine. Remove the auxiliary generator drive. If so, equip the engine oil with separator housing inspection, oil jumper, lens camshaft, bearing brackets, and loose the missing components and seals. Dilution and lubrication. Alright, check. Make sure that all the fuel jumpers, tubes, and injectors are not cracked or are properly seated. Inspect all bronze joints of the top deck fuel with the manifold. Check all the manifold pipe plugs for the leakage. Check with the injector filter cap, jag, gaskets, and leaks. Check for the stuck piston rings. Check with leaking valves in the fuel lines, water contamination, lube, oil, and suspected. Then visually inspect the waters and the oil pan on the top of the cylinder heads with the taking the oil sample for the analysis. Alright, your turbocharged pre-lubrication soak-back system. The turbocharged soak-back pump fails to operate with the engine shut down. Then immediately restart the engine, allow the idle for 15 minutes, and then allow the oil temperature to drop, which cools the turbocharger bearing. The engine can shut down with electrical control. Some soak-back pump circuits can be investigated to determine the cause of the malfunction. If the engine cannot be restored within 2 minutes of the shutdown, it does not restore the engine until the operation of the soak-back pump has been restored. The engine has been allowed to cool down. Inspect the camshaft bearing with the engine top of the deck with the soak-back pump is operated. The oil flow is observed around the bearings as an indication of the check valve located with the soak-back filter housing is jammed open and the variable undesirable condition makes it possible back flush oil contaminants into the main gallery. Removing the housing immediately with inspect the check valve. The soak-back pump filter is mounted in a small canister close to the pump itself. Therefore, it is also bypass valve with the pressure relief valve mounted above the filter canister. There's no backup filtration for the soak-back system. The filter clogs, then the bypass will allow dirty oil to reach the turbocharger bearings. Never extend the charger out or intervals of the soak-back filter beyond the specified scheduled maintenance program. Are the 2 turbocharger oil filter in a large canister on the back of the right bank engine with no bypass valve with the turbocharger oil filter so clogged when the filter may result with a low oil pressure shutdown. The shutdown can occur because of the oil pressure sensing line with the governor low oil pressure shutdown is taken off the discharge side of the turbocharged element. The use of electric motor division recommended filter elements of the resin coated cotton paper within 30 micron rating. They never use the wood pulp filter in the engine maintenance manual electric motor division engine, though the mechanical tank filter elements of the 13 micron rating cannot be used in the turbocharger filter. Caution: change out intervals of the engine mount with the turbocharger filter elements should never be extended beyond the recommendation given in the scheduled maintenance program. Or to check oil delivery with the soak-back system while the pump is operating. First remove the rear of the oil pump handle, cover the left bank of the engine, inspect with the under of the gear train, over the oil return drain with the turbocharger oil drain that's not evident. Check with the motor and pump with the coupling with the boner brush with the pump itself for the failure restriction oil driver delivery. 4. Maintain installations equipped with the indicator light to show that the soak-back pump is being energized with electrical power. The pump does not necessarily mean that the pump is delivering oil to the system. Some installations are equipped with security. The interlock will not allow the engine to be cranked when starting unless the preliminary turbocharged soak-back pump with the primary pumping sequence has been completed. If the engine fails to crank, investigate these security interlocks and failures. or your cooling system, low water pressure and pressure cooling systems only. Install the pressure gauge on the expansion tank with the amount of the pressure rating rise of the tank with the engine heat at the normal operating temperature. If the pressure reading is inadequate to shut down the engine, test the manual vent valve with the close of the next to the expansion tank filter cap leaking when closed. This is done with placing a bucket of water that's over the end of the valve, end of the vent line extends the several inches below the surface of the water. The release of the bubble, the coolant inhibitor through the water intake to the vent valve is not seating properly, must be replaced. Warning, do not get hands or face close to the water bucket while performing this test. Blow down the tank pressure with the opening of the manual vent valve. The tank pressure is completely dissipated. Remove the inspect the expansion tank fill valve. Check the proper seating of the sniffer valve and metal disc in the center of the cap to check for the condition of the gasket. Make a certain pressure for the range of the mark of the cap of the corrected. Alright, installation. If there's indication of the faulty filler cap, remove the check and on external pressure test and then replace the cap if necessary. Warning, on installation with a manual vet blowdown valve, use only the expansion tank caps with the crosswise bars. Protective system designed to prevent injury personnel from the expansion of the hot coolant. For the purpose of the defeat of the plain expansion tank cup is used. The high coolant temperature installation with the radiators. Check coolant level, the expansion of the supply tank with the check with the adequate cooling system pressure. For some of the insulation with a quick disconnect fit for the purpose of the cooling system pressure for the not adequate for the insulation for the check with the under the condition of the expansion tank filler cap. If used, make sure the cap is marked with the proper pressure range. Further, cycle the radiator shutters. If so, equip with the temperature switch test button with the shutter of the test valve to make sure that the shutters are open completely. If necessary, check the temperature at which the shutter control operates. This can be done with either operating the engine until the reach of the temperature at which the shutter opens by removing the temperature switch and testing it separately with a switch can be tested off the engine, placing the heat sensing element on the plan of the hot water with a thermometer, noting the temperature, whether the switch operates. Making certain that all the radiator, water pump, the vent line to place on the non-obstructed disconnected radiator vent lines can cause air binding in the radiators, which results in a loss of cooling efficiency. Water pump vent lines are then disconnected and not to correct the side and can cause cavitation in water pump, which results in loss of coolant delivery pressure. 4A, on the installation of electrical cooling fans, check with the proper installation of all fans, motors, temperature control switches, check all the fan fuses, continuity of the proper rating on installation with the belt driven the cooling fans, inspect the belts to make certain that they are properly in tension. Inspection exterior of the radiator, clogging with the restriction airflow, cleaning radiator baffle fins is necessary. Carefully check for the cords of leaks. Hydraulic testing of the cooling system for leaks. The coolant leak decreases the cooling capacity and the cooling introduced in the exhaust gas in the cooling system. Gases in the cooling system which may cause air binding of the radiators. The water pump do not exceed 24 psi during hydro test. The limit of the non-notable conservative the clown of the old equipment that might have some longer service deterioration. Engine alone blanked off the test with the air with the water at 90 psi. Installation, heat exchangers, and keel coolers. Check the coolant level of the expansion supply tank on the pressure test system. Check both the coolant system pressure and the condition of the filler cap. Check all the vent lines in place and not obstructed. Make certain all the cooling system of the piping is physically located below the level of the coolant in the tank. Check all the cooling system pipe connection tight with all gasket good. With the connection leak of the oil pressure for the output side with the water pump with cause the coolant loss with the decrease of the coolant pressure throughout the system. Leakage with the suction inside input side of the water pump will draw air into the system, which result with the cavitation of the pump, the operation, the temperature control, the thermostatic valve of this installation has equipment. On installation with the engine-mounted raw water pump, check for the valve position with the suction with the discharge circuit with the pump. Make certain the piping connections are properly sealed and tightened that the gasket are in good condition. On installation with the belt and shaft driven with water pumps, check the shaft coupling with the belt and the tension with the check all the valve with the opening with the suction and discharge line with the pumps. Monitor the temperature change across the engine cooling side with the heat exchanger if possible. Raw water pump section with the discharge side with the temperature change is too small across the either side of the cooling side with the heat exchanger. Drop the raw water pump rise the claim of the radiator radiating surface that may be necessary to rot out with the exchanger shell and tube type. R7, the hydro testing cooling system leak for the coolant leak, decrease for the cooling capacity, could introduce the exhaust gas for the cooling system. Gas for the cooling system might cover the air binding of the exchange with the water pump. Do not exceed number 25 psi during the hydrostatic testing, limiting with the non-conservative that might help with the older equipment that might have some of the longer service deterioration. The engine alone could be blanked off and tested with the air with the water at 90 psi. High lubricating oil temperature related with the oil coolant and coolant temperature and problem. Check oil level of the oil pan with the monitoring of the man and oil pressure. The remove of the square covers with the scavenging oil delivery compartment, the train housing. Check the efficient oil delivery from the scavenging oil pump. The oil level should not be more than 2 to 3 inches below the screen of the engine running. If the scavenging oil delivery is inadequate, the machine and filter tank, the pressure should be checked as a test for plug, filters, and jam bypass valve. The purpose of the oil cooler is to use the engine coolant to remove the excess of the heat for the lubricating oil from the lubricating oil. The relationship with the lead to high. The relationship leads to high oil temperature. If the engine coolant temperature becomes too high, determine the engine has had a high temperature problem. The high water temperature reduces the efficiency of oil can cooler by thereby with the higher oil temperature. If the engine has above normal water temperature, the follow the troubleshooting guide with a particular problem. Marine stationary power installation are frequently equipped with a temperature control thermostatic valve. If the engine has equipped with qualifying the opening of the valve on some of the installation failure to valve, the function can be deprived of the oil cooler from the coolant. Put the inline thermometers and temporary thermometers in the wells provided with the engine cooling water pipe with the monitor temperature on both sides of the oil and the water side of the oil cooler. Compare these readings with a standard chart with the locomotive installation with the installation record to determine the oil cooler efficiency. Reduced efficiency is caused by oil cooler plugging, and scale corrosion. If the oil temperature drops, the coolant temperature rises through the cooler and are not adequate, then remove the cooler for the inspection of the cleaning. Your engine performance, unexpected engine shutdowns. Quite often, the startup occasionally with a shutdown of the engine protector buttons may be deactivated with the preferential differential transit that may cover the false indication of the engine problem or during a routine startup and shutdown. The engine shutdown and unexpected while operating under load, the following steps should be performed. Set the position, overspeed, trip level, the reset if it is necessary, control the applicable section of the troubleshooting guide for further investigation procedures. Make sure the engine does not run out of the fuel with the emergency fuel cutoff valve, the engine stop switch is not activated. On the locomotive installation, check the engine was not inadvertently shut down with the moving of the throttle handle beyond the detent position with the right-handed quadrant. Note, the moving of the throttle handle to the right beyond the detent position also shuts down all other locomotives units connected to the tandem. Check with the announcer's module with the fault indication. Look for the illuminated alarm and indicator light with the engine control panel. Observe the engine protector crankcase pressure button. Warning, if the button has popped out, do not work on the engine for at least 2 hours. Do not open any of the airbox, oil pan, or top deck access covers. After 2 hours has passed, the engine can be opened and with inspect for the cause of the crankcase overpressure consult with the applicable section of the troubleshooting guide for the further investigation procedures. 5. Observe the engine protector differential water pressure button. If the button has popped out, check the engine coolant level. If the supply of the expansion tank with the coolant level is low, carefully inspect the engine for the piping external leaks pressure test of the system is necessary, but limited maximum pressure at 25 psi. Remove the expansion tank filler cap cautiously, and the steam pressure may be present. Check that all the drain valves are all fully closed with the engine external piping on locomotive installation. Check that all cab heater drains are closed. Refill the cooling system with the proper coolant with the temp of the restart of the engine. Monitor the engine temperature after load is applied. If the temperature rises beyond the normal level, consult with the higher coolant temperature with section of the troubleshooting guide. The engine protector for the crankcase pressure for the differential water pressure buttons shut down with the engine for the dropping all of the oil pressure through the governor engine oil pressure sensing the diaphragm. Therefore, the governor low oil button should always pop out if one of the engine protectors is activated. The series of the air events takes place with the normal actuation of the crankcase overpressure for the differential water pressure shutdown has entirely different significance than the governor low oil button popping out itself. Check for the governor low oil button if the button below has been popped out. Check for the check oil level of the engine oil pan and the engine mounted oil strainer box. On locomotive installation, a hot oil detector can also cause the low oil button to be popped out. When the oil button is popped out with the hot engine conditions is affected, but they wait 2 hours before checking the oil level. If the engine oil level is unusual low, check the partial opening oil pan drain valve, loosening missing drain pipe plug, low oil evidence chamber below the screen with the square section of the strain with a check with the scavenging oil system indicate with the appropriate section with the troubleshooting guide. If the oil level of the location adequate, with inspect the inside of the oil pan, evidence of the overheated metal surfaces, extruded metal around the main connecting rod bearings, inspecting under and low end of the both gear portraying both for debris. In all preceding steps, do not point out the reason for the governor low indication that can cause the engine to attempt the restart of the engine. If the engine starts with closely observe the engine oil pressure gauge. If the engine does not develop the oil pressure on the gauge, then perform the procedure indicating low engine oil pressure on this troubleshooting guide. On locomotive installation, only if the engine starts over the oil pressure gauge builds over the normal to that could have the hot oil detector that caused the low oil shut down. The hot oil detector might have shut shut the engine down, but then reset itself during the cool-off of the loading of the engine, watching the engine temperature gauge closely with a possible overheating. If after any of the preceding steps of the engine cranked over the rad lead with a failed to start with a fuel system failure is probable, check adequate fuel supply with the storage of the day tank, check for the fuel pressure of the duplex, fuel filters, the fuel flow, for the fuel light glass of the engine, fuel pressure for the fuel flow is not evident, then perform procedure that outlined with the low fuel oil pressure in the troubleshooting guide. On installation with electrical fuel pump, the shutdown could have been caused by an interruption in the fault with the fuel pump control circuit. Using appropriate wire diagram, qualify the switchgear wiring connections, checking the continuity of the electrical interlocks. On turbocharged engines only, if the engine unexpectedly shut down when the throttle was reduced, accompanied by the bogging of the engine, heavy smoke with the turbocharger clutch, maybe failure to engage properly, check the operation of the turbocharger clutching using the electric motor division turbocharged troubleshooting procedures. On locomotives installation only with the several unique characteristics of the control system could cause the unexpected reduction of the engine speed while the operating under load. Unexpected locomotive engine speed reductions can be caused by activation of the THL or EFL protective relays. The relays are a function to produce the engine power with a hot engine. Clogged air filter conditions occur on most freight locomotives. The application of the pickup of the TH and EFL will reduce the number 8 throttle to the engine speed, number 6 throttle, number 7 throttle. The throttle was engine speed, number 5 throttle. Check the announcer indication for the fault light. The engine control panel. Check the engine temperature control system. Change the air filter elements necessary to correct the problem. Qualify with the control stand micro switches. Inspect the connection with the control of the wire, flexible of the cable, the governor's tightness of the terminal engagement. Pick up the ground protective relay will cover the engine speed that reduce the inner idle regardless of the throttle position action that's accompanied by an announcer and indication of the engine control panel light and an alarm. Alright, your loss of power. On installation load regulator, load control system, the correct injector that is essential for the proper loading of the system. When improper loading occurs with this type of system, check with the injector part number that makes certain that they are correct for the installation. Engine runs with a clean stack. Shut down the engine, open all the top deck covers, visually inspect the injector racks and followers, make sure that all the injectors are engaged with the transform, the arms of the all pins and linkages are in place, properly tightened. Observe the fuel jumper, the rocker arm with exhaust valve bridges for any abnormal conditions. Close deck cup, covers, prepare the normal startup, check the fuel supply, primary engine fuel system, check for the adequate return fuel flow with the sight glass fuel system, supply pressure, duplex filters. Start the engine, allow the reach of this operational temperature of the fuel system, pressure delivery fuel system shows an indication of the inadequate delivery, then follow the procedure outlined in the low fuel oil pressure and the troubleshooting guide. If the bubbles are evident in the return fuel sight glass, section 5B of the low fuel oil pressure troubleshooting, the following procedures apply only to the engines with notched continuous throttles of the Woodward PG, PGR, and PGA governors. With the engine not overloaded, attempt to slowly increase the engine speed for the idle maximum of the RPM without the installation of the PG, PGR governors. Check for all the assigned engine speed with the properly activated. On the installation with the PGA governor, check for the engine speed responds to the evenly increased throttle throughout operating range of the operating range of the idle to maximum RPM. Using a hand tachometer, check the engine has reached maximum speed. The engine failed to reach the maximum RPMs. Check the governor solenoids, PG and PGR governors, and the control air supply with the pressure setting with the PGA governor. Return engine speed the idle and attempt to load the engine. Advance throttle slowly, smooth from minimum maximum speed. Qualify the maximum speed of the engine with a hand tachometer. The engine cannot reach the maximum speed rating under load. Examine the position of the rack and indicate with the quadrant of the governor. Verify the following conditions while under full load. If the governor rack is shorter, then specify the maximum position of the governor nameplate. While under full load, the engine is running at or below maximum rated RPM. On the locomotive installation, check the position of the load regulator. If the load regulator has moved the minimum field position, the problem is most likely the mechanical nature. Carefully inspect mechanical condition of the injector to check for correct part numbers. The injector should also be pressure tested. Injector pressure test is in this section of the governor part number that should also be checked to make sure for the right one for the installation. Remove the necessary for the governor should be removed to check the load regulator. If the load regulator has moved the maximum field position, probably could be either mechanical, electrical nature. Injectors should be properly be checked. The proper part number of the pressure test of the electrical excitation system should be qualified in accordance with the procedure established in appropriate locomotive service manual. On a marine or power-generated installation overload condition with a mechanical problem, the fuel injector is most likely the pressure test of the injectors after checking the correct part number. Refer to the injector pressure test. In this section, make certain that the governor part number that is correct with the installation of the governor and injector function properly with these parts verified with the installation. The electrical and mechanical overload conditions probable on power-generating installation. Refer to the load rating of the condition with the applicable manual of the marine gearbox installation. Refer to applicable proper cube curves to determine if an overload condition exists. If the governing rack is longer than the specified with the maximum position with the governor nameplate with the engines operating below the maximum speed, attempt to increase the fuel injection, shorten rack dimension by manual advancing the lay shaft lever. If they increase the resistance prevented with the injector cover lever with being manually advanced the specified maximum position, then suspect that either the engine injector rack is binding or the governor stop adjustment on the power piston is improperly set. If it was possible to manually advance the injector control level to maximum fuel position, the engine speed increase, then suspect the improper governor setting, high speed unloader limit, marine only, deliberated speed limited setting, locomotive only, improper adjustment governor. On the PGR governor of the rail and drill rig, the governor should be removed from the engine with the operator with the governor testing stand with the make an adjustment to check with the governor injectors part numbers to make sure that they are correctly that their particular application. Engine runs with the dirty stack. Open the top deck cover to perform a visual inspection of all injector racks of the followers to make certain that all the injector racks are engaged with the transformer, the arms, all pins, linkages are in place to properly tighten. Check the injectors for proper part number, the pressure test, and injectors. Check for linkage for the re-injector pressure test for the section. Close the top deck cover to prepare the system for a normal startup. They observe the fuel system pressure delivery with the abnormal condition fuel system delivery with the pressure low. Refer to low fuel oil pressure section. The troubleshooting gather the bubbles are evident with return of fuel sight glass to section B, section 5B low fuel oil pressure troubleshooting. With the engine at normal operating temperature for the normal under low, the slowly advance the throttle from the idle segment of maximum speed. Check all the engine speed will reach smoothly. Verify the maximum engine speed with a hand tachometer. With the engine maximum speed, full load applied with the water manometer check with the exhaust back pressure. And below engine, the back pressure should not exceed 22 inches of water. Turbocharged engine, the back pressure should not exceed 5 inches of water. If the exhaust pressure is too high, check for the obstruction on the exhaust riser stack extension. With the engine max speed, with no load applied with the use of the water and manometer to check the engine air inlet depression. The air inlet depression can see the valve provide with the air filter pressure drop data either change or clean filters. No, all filters pressure drops are measured with a clean air polonium downstream of filter elements. And it shows the chart of your air filter pressure drops. Attempt to load the engine bugs and smokes, and check success with the air block accumulation blocking inlet ports, turbocharged engine, check with the plug with the exhaust screen, qualify the condition of the turbo to perform the inspection outline turbocharging troubleshooting selection. If the preceding checks are proved with a negative, qualify with the engine time and the checking the exhaust valve timing on both cylinder banks. Alright, cylinder misfires pressure over the test. All injectors using the appropriate in the electric motor division tool of the tools. Check for the free follower with the action adequate injection force. Inspect the part numbers of the bodies of all the injectors. Verify the entire engine to get set with the correct reading of the installation. Also, the electric motor division does not make hollow rack injectors. Hollow rack injectors can be set correctly with the electric motor division injector rack tool. If they are mixed with the electric motor division engine set, the electric motor division injector set with the electric motor division tool. These cylinders will be too light on the fuel volume rack too long. This can result with a misfire, vibration, poor overall fuel economy, and possible serious damage to the engine. On installation with the fuel side glass, check for the adequate fuel flow. With the return side glass, the fuel flow is inadequate. Refer to low fuel oil pressure section with the troubleshooting guide. If the bubbles are evident, return the fuel side glass. See section 513. Low fuel oil pressure troubleshooting on installation fuel block duplex filters. Check the adequate fuel supply pressure. If the fuel pressure is adequate, inadequate. Refer to low fuel oil pressure section on this troubleshooting guide. Inspect the exhaust valve. Check for the valves that are stuck partially open, operating with the damaged hands and misadjusted. So they cannot completely. This can't seal completely. Alright, engine knocks. Perform a complete top deck inspection. Check with the injector control linkage. If the bubbles are evident, return the fuel side glass. The engine over running. See section 513 low fuel oil pressure troubling. Troubleshooting, repairing the injector linkage with a loose adjustment lock nuts, missing pin clips. Make certain that all the injectors are properly engaged between their racks and control linkage pressure. Test of all the injectors. Refer to the injector pressure test and inspection. Set the time in all the injectors in accordance with the procedure provided at the end of the section. Check the exhaust valve with the last adjustment. Remove the test for the valve bridge with the show of the adequate last adjuster tension, which operates loudly when the engine is running. Check all the injector parts of the number to make certain that the entire engine set is correct with the installation. Check with the engine overloading, overheating problems. Observe the loading temperature of the gauge for the engine for the operation necessary. Refer to the applicable section of the troubleshooting guide for the corrective action. If the preceding step of the negative to perform the following steps, although these more unlikely to cause the engine knocking. Check the exhaust valve with the timing on both cylinder banks. Carefully inspect the engine to make certain that the 567-645 power assembly have not been mixed with the same engine. 567-645 power assembly can be operated at the same time in the same engine because of the difference of the weight and the make of the counterbalance impossible. An entire set of 645 power assemblies can be used in certain 567 engines, providing that all the instruction and electric motor division modernization recommendations of the subject are filed with consult your dealer electric motor division representative for more information. Make certain that the blower type of the piston with the turbocharged piston are not mixed in the same engine with the check piston with the part of the numbers bottom piston skirt from inside of the oil pan. Take the lead wire readings to check for the bent and rods and piston pins for the insert distress. Heard excessive vibration on top deck cover to perform visual inspection on all injector racks and followers. Make sure all the injector racks are engaged. Transform arms, all pins and linkages are in place properly. Tighten pressure test and injector link. Refer to the injector pressure test. In this section, bubbles are evident. Return fuel sight glass for the engine running. See section 513, low fuel oil pressure troubleshooting inspection. Engine generator coupling disc for engine evidence failure. Marine installation, inspect the torque tube couplings deliver the evidence of failure. Inspect all drive shaft of the operating auxiliary equipment for the any sign of the failure. Remove oil pan, handhold cover to visually inspect the crankshaft or area with the loose for the damaged main cap bearings, connecting rod baskets. Look for signs of overheated extruded metal. Inspect the debris using the gear train at both ends of the engine. Visually qualify the crankshaft diameter to check with the engine records to make certain the crankshaft diameter is not past the change of the due date. Inspect the top of the deck on both banks of the cylinder with the broken rocker arms of the broken rocker arm shaft, the mounting studs. If the installation has been subjected to any shock loading, checking the engine generated the engine gearbox alignment. If the engine was recently overhauled, check the camshaft counterweight timing. Engine smoking, dark smoke. Alright, check the governor rack quadrant with the engine with the maximum rated RPM full load. Indicate with the governor quadrant dimension shorter than the limit specified by the governor indication plate with the engine may be operating overload. If the bubbles are evident with the return fuel sight glass, section 513, low fuel oil pressure troubleshooting. Check maximum engine RPM with a hand tachometer with the end of the camshaft of the engine is running below the maximum rated RPM with short on the rack. Overloading is most of the probable cause. The following steps should be taken. On locomotive power generating installation, standardized horsepower output. Check all the calibration, load, and control, adjusting in the possible adjustable to obtain the proper rated output. Alright, on the marine gearbox installation, it may be necessary to adjust the pitch and diameter of the proper propeller if it's continually overloading experience. If the engine was overoperating below the load limit, remove the load with the run of the engine is maximum rated with the RPM without load. Check the engine air filter inlet depression with the water tube manometer. If the inlet depression exceeds the value provided with the engine running with a dirty stack, then change the clean air filter. Check the exhaust back pressure. If the exhaust back pressure exceeds 5 inches of water, turbocharged engine, or 22 inches of water with a water blower engine with the look of the blockage with the restriction of the exhaust system. If the preceding checks don't prove negative, shut the engine down. Perform the complete inspection with the injectors. Make sure all the injectors are the correct part number of the installation. Check with the injector time and the braking setting. Pressure testing all the injectors for leaks. Refer to the injector pressure testing and inspection. In this section, check the exhaust valve timing on the both banks of the cylinder. Perform a complete airbox inspection. Check for the broken compression ring. Caution: never operate electric motor division engine in the routine circuit with the broken compression ring. The ring fragments can be drawn through the linear air ports into the inlet air stream, where there may be damage to the liner and piston, cylinder heads, exhaust valve. The pieces of ring can also be drawn from the exhaust stack, where they could be damaged to the turbocharger if so equipped. On blower engines only, check the leaking shaft at the end of the seal with observing the airbox end of the air with the delivery chutes of the oil flow. Leaking end seal can be an indication of the impending of the bearing failure with a possible rotor damage. 7B, on turbocharged engine, only remove the inlet with the boot, with the inspect for the inlet impeller with the further damage, remove the section with the exhaust manifold adjacent from the turbocharged, examine the condition of the protective screen, clean the necessary, and inspect the interior exhaust manifold debris, have someone else rotate the turbo shaft with the inlet with a while respective the exhaust blade with a flashlight, refer to the turbocharger troubleshooting in this section. Or speed departure engine speed hunting. Make certain that the engine control linkage is working properly. Replace the injector showing evidence of the racking binding. If the bubbles are evident, low fuel, return sight glass C, section 5B, low fuel, oil pressure troubleshooting. Check with the governor for correct oil level, either too high or too low oil level. The governor may cause the engine hunting, and if the governor manufacturer oil level is constantly rising, if the governor oil becomes excessively dirty after short operating time, the engine lube oil is getting into the governor oil. Check for the following possibility. The governor oil pressure sensing diaphragm may be ruptured, load control pilot valve. If so equipped, they may have failed seated. Seal, if the problems may be required the removal of the governor for the correction of the rebuild, while the engine running will vent with the air bleed screw with the governor body to remove any of the trapped air for the governor control pass, adjust the compensating needle valve to limit the hunting condition as much as possible. If hunting continues, the cause may be the following on locomotive installation operation protective devices, such as current overload relays. Excitation limitations may cause hunting of the check of the electrical system, make certain that the excitation circuits are function properly. And on drill rigs on DC power generated installation cycle calibration overload relays may cause hunting. Check leak circuits in proper operation. Note: marine engine gearbox installations may exhibit a load fluctuation in rough and shallow water, which should not be confused with hunting. And then it goes into protective devices, and we're going to have the tape there.